solving 1 and 2-step equations. The goals of this lesson are, by the end of the lesson, students will be able to solve 1 and 2-step equations by using step-by-step process presented to them in class or your video. They will also be able to check their answers by plugging them back into the original problem. Now, solving equations is a little different than order of operations. Why? Because in order of operations, most of the time we're talking about an expression. When we're talking about an equation, this means we have an equal sign. Solving for 1 and 2-step equations means we're looking for the missing value or the variable. This should be familiar to you from Algebra 1. Now, just as a review, you must use inverse operations to solve an equation. The inverse operation or the opposite operation for addition is known as what? What's the opposite of addition? Subtraction. What is the opposite of subtraction? Addition. What is the opposite of multiplication? Division. What is the opposite of division? Multiplication. Okay, that's just review. Now, the other thing to note is that when you are solving equations, you want to solve them in reverse order of operations. If you remember order of operations, we went PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. When you solve equations, you're going to go SAD-MEP, subtraction, addition, multiplication, division, division, multiplication, exponents, parentheses. That means you have to undo all the addition and subtraction first, and then multiplication and division next. So one big thing that I always tell students, especially as the equations get more difficult, always take a look at the entire equation and think before you just start solving. Okay, so decide what operations must be used to solve. Do them in reverse order of operations, and we just talked about this. You want to do it in SAD-MEP order. Check your answers back in the original equation. Okay, you should never miss solving equations because you can always go back and check. Okay, remember, whatever you do to one side of the equation, you must also do to the other side of the equation. It's like a balance. So in this case, I have 3 plus p equals 8. Like I said, we're looking for the missing variable, the value of the missing variable. Now you might know this just by looking at it, but just for practice, let's go ahead and solve the equation using opposite operations. 3 plus p equals 8. Well, since this is attached by addition, or also this is a positive 3, how do we get that to 0, or how do we eliminate it? We're going to subtract 3 from both sides. We're going to do the opposite operation. 3 minus 3 is just 0, so I have p equals 5. Okay, now to check your answer, you have 3 plus, and then we said p is equal to 5, so we're going to replace p with 5, and 3 plus 5 is 8. So that checks out. Next one, x minus 7 equals 13. Using the opposite operation, opposite of subtraction is addition. We're going to add 7 to both sides. X, or negative 7 plus 7 is 0, so I have x equals 20. Go ahead and check that. 20 minus 7 is 13. 10n equals 40. Just a reminder, if you see a variable beside a number, we assume multiplication. A dot also means multiplication. If you have a parenthesis, it also means multiplication. Multiplication can be written so many different ways. 10n, 10 times n, can be written 10n, or 10n, or it can be written actually 10 times n. So those all stand for multiplication. Now, how do we get rid of the 10? We're going to go ahead and do opposite operation, and we're going to divide both sides by 10. 10 divided by 10 is 1, so we just have 1n. 1 times n is n. 40 divided by 10 is 4. Let's check that. 10 times 4 is 40. Now we have a division problem. This line right here means division. M divided by 4 also looks like a fraction. Fractions and division are the same. M over 4. How do we get rid of division? What is the opposite operation of division? multiplication, so we're going to multiply both sides by 4. 4 divided by 4 is just 1, so we're left with m over 1, or just m, equals negative 13 divided by 4 is negative 52. Check your answer. So negative 52 divided by 4. If you're not sure, you can actually do long division, or you can use a calculator. 4 goes into 5 one time. 12. 4 times 3 is 12, which zeroes out. So we'd have 13. Now we know that a negative 52 divided by a positive 4 would give me negative 13. So add your negative, and that checks out. Now we have a multiple step equation or a two-step equation. We have a negative 9 times x plus 1 equals negative 80. So in this case, we have two operations. Which one do we get rid of first? SADMEP, subtraction and addition. So we're going to subtract 1 from both sides. 1 minus 1 is 0, so I have negative 9x plus 0, which we don't have to write. Negative 80 minus 1 is negative 81. Now I have multiplication left. Remember, this stands for multiplication. So I'm going to divide both sides by negative 9. X equals 9. Negative divided by negative is a positive. Let's check our answer. So I have negative 9 times, replacing it with 9, plus 1 equals, well, this gives me negative 81 plus 1, which is negative 80. And that checks out. Now we have division and addition. Usually we would get rid of the addition first because of SADMEP, you get rid of subtraction and addition. However, if you remember from order of operations, I told you this long line right here stands for, it has imaginary parentheses, everything on the top and everything on the bottom. Okay, and since there's only one thing on the bottom, we can just say everything on the bottom is just negative 16. So in that case, we have to get rid of the negative 16 first, okay, because parentheses are last in SADMEP. Okay, if you remember, if these are assumed to be in parentheses up here, we have to get rid of the negative 16 first. So I'm going to multiply both sides by negative 16. Negative 16 divided by negative 16 is 1. So I have n plus 5. Negative 1 times negative 16 is positive 16. And now I have addition, opposite of addition, subtraction. So I have n equals 11. Let's check those answers. So 11, so I have 11 plus 5 over negative 16 equals negative 1. Actually, we don't know if it equals negative 1 yet. Let's erase that. My fault. So 11 plus 5, since that's in parentheses on the top there, we'd say it's 16 divided by negative 16 is negative 1. So yes, that was correct. Now, this one's a little bit different. Notice how the subtraction is on the outside of the division problem. In this case, since we still assume parentheses for the division problem, which they would look like this, but the negative 1 is not inside with that. Since that's the case, we do want to get rid of the subtraction first by doing the opposite operation and adding 1. So I have m divided by 9 equals negative 2 plus 1 is negative 1. How do I get rid of division? I multiply. Opposite of division is multiplication. 9 divided by 9 is 1. M over 1 is just m. Negative 1 times 9 is negative 9. And now let's plug that into my original. So I have negative 9 divided by 9 minus 1, which gives me negative 1 minus 1 is negative 2, which checks out. Now, this is actually a two-step problem, and a lot of times students mess this one up, so make sure you pay attention. Now, this just means 3 minus m, or 3 plus negative m. A lot of students see the subtraction there, and they want to go ahead and add 3, okay? If you do that, you will be wrong, okay? 3 plus 3 is actually 6. And you want to try to get rid of the 3. Okay? So what you want to do to get rid of that, let me rewrite this, is think to myself, okay, this is actually positive 3 and this is negative 1m. Okay, so this is actually a multiplication, negative 1 times m. That means I'm going to subtract 3. What's 3 minus 3? It's 0. That, now it cancels. So now I have negative 1m equals 3. This is now a multiplication problem. Divide both sides by negative 1. I'm left with m equals negative 3. Plug that back in. Check the answer. 3 minus negative 3. Well, minus a negative is actually just plus a positive. So I have 3 plus 3 is 6, which checks out.